Hi, this is second video in the plane geometry series. We begin with parallel lines. So here is what we can do. Take a ruler and use both sides of the ruler to draw two straight lines. These two lines will be parallel. And we generally use arrows pointing in the same direction to denote parallel lines in geometry. Now, whenever two parallel lines are cut by a line, and this line is called transversal. We notice that there are several angles that are formed. So there's one angle here, let's call it A. There's one angle here, B. Then one more here, one more here, A, B, C, D, and then there are four more here. Call them E, F, G, H. Now, if you use a protractor and try to measure all these 8 angles, you're going to observe something. Angle A is acute. You can see it's less than 90 degrees. And so is angle E, and angle G, and angle C. So there are 4 acute angles. And you also notice that those acute angles will all be equal. And if two angles are equal, then we denote them by using an arc. So I'm going to draw an arc around A, and I'm going to draw an arc around C. Whenever we write like that, that means we are trying to say that these two angles are equal. And E is also acute. So all the acute angles are going to be equal. Now angle B is obtuse, and there are 4 obtuse angles in all. So B and D, they are obtuse. B, D, F and H are obtuse angles. And you will also realize that those obtuse angles are also equal. So if B is 120 degrees, then the other obtuse angles will also be 120 degrees. And that's how we are going to denote. We want to tell that B and D are equal, but we cannot use the same single arc that we earlier used to denote the acute angles. So now when we write in this way, we are saying A and C are equal and B and D are equal, but that pair of AC need not be equal to the pair BD. So they are separately equal. And similarly, I can write F and H that way. And also notice that an acute angle and an obtuse angle is actually, in this case, A and B is a linear pair. But even if they're not linear pair, like E and B are not linear pair, they are supplementary angles. So what we notice is whenever two parallel lines are cut by a transversal, then the angles formed are either equal or they are supplementary, which means if A is 40, then B is 140. Now, if A is 40, then I can also say that H is 140. So that's one observation we want to make. Now, notice your lines would have to be parallel in order for those nice properties to hold. Now, some terminology here. So let's go ahead and redraw another set of parallel lines and a transversal, because that picture is already too cluttered. So we have two parallel lines and we are cutting them by a transversal. And notice this angle we called it A, an acute angle. This was A and this was E. Now angles like A and E are called corresponding angles. So there is this term, corresponding angles. Now, because both A and E are on the same side of the transversal, and also since these are parallel, you will need same amount of rotation from going from this parallel line to the transversal as you need it to go from this parallel line to the transversal. Now, one other thing. The space between the parallel lines is called interior and outside is called the exterior. So, A and E are corresponding angles, and let's go ahead and label this angle, which was C in our previous picture, and that's also acute. So C and E, they are in the interior space and they are on either side of the transversal. So we call them alternate interior angles. Alternate interior, alternate because they are on either side of the transversal, interior because they are both inside, they're both in the interior space. Now, this acute angle, EF, and this would be G. So notice A and G are also equal, and they are both on the outside, so they are in the exterior, and they are also alternate. So A and G are alternate exterior angles. And notice A and C, we have seen these angles in the previous video. They are called vertical angles. And when two parallel lines are cut by a transversal, we get several angles, and these are all going to be equal. Corresponding angles are always equal. Alternate interior angles are always equal. Alternate exterior angles and vertical angles, they are all going to be equal. Oh, this line, let's remember, this is called transversal. Now, this idea of two parallel lines cut by a transversal giving rise to so many angles with nice properties will lead us to some powerful results in geometry. So let's go ahead and talk about a triangle. So what is a triangle? A triangle, tri means three, angle means angle. So a triangle has three angles, and not just three angles, but it has three sides as well. So A, B, and C are the three angles of a triangle. Now, what can we say about these three angles, A, B, and C? Here is what we can do. We can try to draw a line parallel to BC, but going through A. So let's go ahead and make a rough sketch of a line. I'm going to draw it dashed. It's not part of the triangle. So these two lines are parallel. So notice A and B are, AB is a transversal that's cutting these two parallel lines. So if you can spot alternate interior angles here, this is what you see. This angle, which is outside the triangle, will be equal to that of B because they are alternate interior angles. Now again, on this side, AC is another transversal. And where do you see alternate interior angles there? Right here. So let's denote the equality of these two angles by a triple arc. And let's just use a single arc for A. I cannot say that A is equal to either B or C. A, B, and C could be completely different angles. But what do we notice? If you add all the three angles, A plus B plus C, this is as good as adding these three angles, which all form along this straight line. And what is the angle along a straight line? So if you have a straight line and if you measured this angle, you get 180 degrees. That's straight angle. And what's happening here is this straight angle is being split by these two transversals into three angles. So these three angles should add up to 180 degrees. So from the alternate interior angles property, we find a nice result for a triangle. So, and we can call it as a theorem. And if you want, you can name it as angle sum theorem. So what is that theorem? It says sum of all the angles in a triangle is 180 degrees. So regardless of the size of the triangle, size or orientation, you may have a really tiny triangle, a small triangle, or a huge one. It does not matter. You may have a triangle that has a right angle in it, or it does not matter what triangle, whatever triangle you're going to consider, all the angles will always add up to 180 degrees. That's a very useful statement. All right, now that we started talking about triangle, let's try to group them according to the side lengths. So if you have all the angles, all the side lengths equal, that's called equilateral. So what is an equilateral triangle? An equilateral triangle has all the side lengths equal. In fact, lateral just means side. So equilateral means equal sides. And how do we denote equality of sides? Well, we use tick marks. So if I put a tick mark on that side and also the same tick mark on this side and this side, what I'm claiming is all these three sides. So let's say AB, C, then AB is equal to BC is equal to CA. So that's what it means. An equilateral triangle is a triangle that has all sides equal. Now, sometimes you may have a triangle in which not all three sides are equal, but only two of them are equal. Now, those triangles have a name. They're called isosceles. So what's an isosceles triangle? It's a triangle in which two sides are equal. So if I draw a triangle with AB equal to AC, but notice BC need not be equal to them. So let's go ahead and write AB is equal to AC. Now that triangle is called isosceles. So notice that an equilateral triangle can be thought of as an isosceles triangle. So if an isosceles triangle has a property, then an equilateral triangle will also have that property because all equilateral triangles are isosceles. they are more than isosceles, so they are definitely isosceles. All right, now it may so happen that none of the sides, no two sides in a triangle are equal. Now, such a triangle is called scalene triangle. So you can draw a scalene triangle. Since no two sides are equal, we are not going to use any tick marks. So this classification, based on the relationship between the sides of a triangle, equilateral, isosceles, and scaling. Now you can also group triangles based on the angles. Now notice all the angles of a triangle always add up to 180 degrees. So it's possible that a triangle has all acute angles. So if I have a triangle where all of the angles are acute, acute means less than 90 degrees. So A, B, and C. So A is less than 90 degrees, B is less than 90 degrees, and I'm not saying they're equal. That's why I'm using different number of arcs to denote them. And C is also acute. That's called an acute triangle. Now a triangle could have a right angle. So that's called a right triangle. So what is a right triangle? You can have a right angle. So notice we use this special symbol to denote a right angle. So you may have a right angle in a triangle. So ABC. But notice you cannot have two right angles, because a right angle is 90 degrees and all the angles should add up to 180 degrees, which means there can be at most one right angle. So if you have a right angle, then what can you say about angles A and C? What should they add up to? So I'm using different number of arcs to denote A and C, but if B is already 90 and all three add up to 180, then your angle A and angle C should also add up to, well, what is 180 minus 90? It's going to be 90 degrees. Now, and what do we call those kind of angles that add up to 90 degrees? They are called complementary angles. So in a right triangle, the two acute angles are complementary. And then you may also have a triangle where one of the angles is obtuse. So that's called an obtuse triangle. So what is an obtuse triangle? If you are going to have one obtuse angle, and notice this is already more than 90 degrees, which means the other two have to be really small angles, because the total has to be only 180 degrees. So if B is obtuse, then A and C will be small angles. In fact, the total will be less than 90 degrees. Now that's the classification of triangles based on the side lengths and based on the angles. In the next video, we will talk about congruence of triangles.